welcome again to another session on non-parametric statistics. The last time we looked at the overview of the non-parametric statistics and then the various types that we had, and we want to look at in this series. Today we are looking at the sign test, and that is the test on a single mean. So how do we do a test on a single mean? This is a one sample case. For a reasonably large sample size, the random variable x has approximately a normal distribution with mean mu and variance sigma square over n regardless the distribution of x. So if we have a very large sample size, we can use the normal distribution to actually do the test, that is the z-test, with variance known, or we use the t-test if the variance is not known. So what if the sample is less than 30 or it is small? Do we still go ahead with the normal distribution approximation or what? So the central limit theory in some of the books, they assume that if your data is more than 25, then it is large enough to approximate. In some other places too, they consider 30 to be large sample, greater than 30 to be large sample, that you can use the normal approximations. So what if you have less than the 30 in those books and the 25 in the books that states 25 or more? What do we do in that case when we have a non-normal situation? The sign test is used to test hypothesis on the population median. The mean is affected by extreme values, and so it is not advisable to use the mean to make conclusions or to describe your data when you have outliers in your data set. Given a random variable x, m is defined such that the probability of x less than n is less or equals to 5, and the probability that x is more than the median is equals to 0.5. So in short, you have this. So this is the left side of your data set, and this is the right side of your data set. So the probability of getting a value less than m, you have equal numbers here and equal numbers there. Alright, so that is simply the median. Pick the middle value. If the data set is even, it means you have two data points in the middle, and you can still find the average of those, and that becomes a median. So again, you have an equal number of observations to your left hand side and an equal number to your right hand side. That is what this little thing here is telling us. So the hypothesis we usually state as the mean is equals to mu naught against an appropriate alternative on the basis of a random sample of size n. So the sample that we have mu, we take that from the data set. Okay, estimate this from the data set, then we test this against the population value, or the value that we want to test against. Okay, so whatever that value is, we do the comparison. If the distribution is symmetric, the median and the mean should be equal. That is true. We saw in normal distributions that if the data set is normally distributed, your median here should be equals to the median, and in most cases equals to your mode as well. Okay, but we're not considering this at this time, so we want to look at the mean and the median in describing your data set. So the approximate test statistic for the sign test is the binomial random variable x, representing the number of plus signs in our random sample. Why do we consider the plus sign, or why do we consider the binomial situation? Now, binomial indicates that if the data point, if our median is equal to, let's say, 3, any number that is less than 3, you're placed in the left side of m. If the number is more than 3, you place that in the right hand side. If it is 3, that is 0, and we don't count that as the plus or minus. So we are going to consider all the numbers that are to the left, that is minus, and all the numbers to the right of 3, that is positive. So we count these numbers and use the binomial distribution to approximate the probability of getting a plus sign or a minus sign. How do we make decisions regarding the null and alternative hypothesis? So in testing the h naught as mu is equals to mu naught against mu less than, so we have a varied situation here. If we are looking at less than So it means our interest is lying, the alternative hypothesis is concentrating on the minuses that we have here. Alright, so we reject H0 in favor of H1 only if the proportion of plus signs is sufficiently less than half. So the probability that we have the plus signs less than half, then we say, okay, this we reject H0 in favor of the H1. Now, if we compute the p-value, this is how we compute that p-value using the binomial distribution, and it is less than some pre-selected margin, say 0.05. If we do this calculation and this probability is less than 0.05 in this 0.5 in this case, then we reject H0 in favor of H1. For example, let's say we have a sample of 15 observations. Now x is equals to 3, and we find the probability of x less than a capital X less or equals to 3 when p is equals to half to be this in our table. So we use the normal distribution table to actually look at this. Okay, so looking at it in this table, we have n equals to 15. The binomial table is very large, so I just take a snapshot of what I want in this case to show you how it is read in the table. So we have n equals to 15 and we have r here equals to 3. So this is 3, and if we are looking at the probability of this one, that is the p-value, which is equals to 1/2, then our p probability value, that is the p-value, is equals to this. So you simply trace it here and trace that down here where the two meet. That is the value that you pick right here. So it's fairly simple. Just count the number of pluses or minuses and look the answer up in this table. Alright, so if you don't have the table, this is what you can do. Using Excel, you can say, let me write it up here. So write it as this binomial binom dot distribution for short. So this is a dot. Then inside the parentheses, we are going to write this inside there. So for this case, this example, you write the x first, that is 3, comma. You write 15, the number of observations, comma. Then you write the probability there, 0.5. Then, comma, true because we want the cumulative, not just the probability at one point. We want the cumulative probability up to, from 0 up to 3. So this is how you can get the same reading as 0.0176 from Excel without the table. Now, what if our alternative hypothesis is different? The null hypothesis still remains the same as equals to, but then the alternative this time is greater than but not equal, but not less than. So we reject H0 in favor of H1 only if the proportion of plus signs is sufficiently larger than half. So in the less than case, we consider the case where they were less than half, but this time we're talking about greater than in our alternative hypothesis, and our decision is to reject the null hypothesis in favor of the H1, that is alternative hypothesis, only if the proportion of plus signs exceeds half. So if we compute the p-value for this particular one, it's the same thing as before. So this is how we're going to do that one. Now, in terms of calculating it manually, this is not read in the table. We don't have this. So what we can do here is that it's more like a number line. Okay, so we have the half one here. This is greater than, this is less than. Let me put it that way. So we are going to start from somewhere and start adding up to a particular point. But looking at this one, it's going to jump us from this point up to some point. And what about this? We don't know this one. So the best way to handle this is to know that whatever that is here from here up to the end plus whatever would have been here, if I add the two of them, let's say 1 plus 2 here, I should get a probability of 1. That is the probability of the distribution, provided it's a probability distribution like binomial, should be equals to 1. So if I know this idea, then I can simply say, okay, let me say the p-value x less or equals to 3. I can find this one, but I cannot find x greater or equals to 3 on the table. So the calculation on the table is based on this one. Okay, so once this is greater or equals to, this should be strictly less than. So if I add these two, I simply get 1. So why don't I read this one right here and subtract it from 1, then I can get what is here. So that is what happens here. Okay, so in actual fact, we are reading the probability that x is less or equal to 3 from the table, and now subtracting that from 1 in order to get the required probability value. This is how we read the table. Now the third one is when we are talking about not equals to. So in this case, whether it's less than or it is greater than, we still will not accept it. So that means that the null hypothesis should strictly be equals to the hypothesized value. Anything sort of that is rejected. So in this case, we reject the h0 in favor of h1 only if the proportion of plus sign is sufficiently less than or greater than half. So whether it is less than half or more than half, we will reject the null hypothesis in favor of the alternative. So we compute the p-value here as this. Now you're seeing the difference here, that there is a 2 here. That's because it's a two-way. Okay, so it's two-way, we multiply that by 2. So whether it's greater than or less than, we still have the same answer coming up. Multiply by 2 and you get your p-value. So in this case, we reject the null hypothesis in favor of the alternative if either of them is less than alpha. And our alpha, we are setting this to be our alpha 0.05, and that will give us help us to make our decision regarding rejecting or not rejecting the null hypothesis. Whenever the sample size is more than 10, the binomial probabilities with p equals to half can be approximated from the normal curve, since the product of the sample size and probability is greater than 5. Okay, so when this happens, we can go ahead to use the normal approximation to normal curve to approximate our solution to the binomial situation. Let's take an example. Consider the following data and that represent the number of hours that employees of a given company spend watching football during working hours. So this is the data set that we have. So we want to use the sign test to test the non-hypothesis, the hypothesis that the median hours of productive hours lost to watching a football game by the employees is 1.8 hours. So our null hypothesis will be that our mu is equals to 1.8, and then our alternative is lost to, so more than 8. So we use this, and in another case we want to test 1.8 as well. So whether you spend less or you spend more, we want to see the two, all of them. Okay, so from the data we determine the number of values greater than 1.8 and values that are less than 1.8. So in short, we are going to consolidate these two to say that, okay, let our alternative be that it's this 1 point not equals to 1.8. Look at 1.8 and look at the numbers that we have here. So this would be minus because it's less than 1.8. This is more than 1.8, less than, more than, less than, equals to. So we don't do anything to this one. This is less than, this is greater than, this is less than, and this is less than. So we have 1, 2, 3. So 3 positive values, and then we have 1, 2, 3, 4, 5, 6, 7 negative numbers. Alright, so this is how we're going to get that. And we look at the probability of, we would have used the binomial distribution in Excel to find the values as this. So we have positive numbers which are equal to 3, then the sample size. So in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But then because this is not part of the plus or minuses, we have one less, so that will be 10. So not 11 but 10. Then our probability here, we are looking at 0.5. Alright, so do this and we get our solution from the table. 3. We determine the sample size from the resultant, just like I indicated earlier on. How do we determine the sample size from the data set? When we count the data points, we have 11 of them, but then one of them is not a positive or a negative, so we subtract that from the original sample size. Then we have 10. This is the resulting sample that we are going to work with because of the plus or negative signs. So we compute the p-value based on the binomial distribution as this, which is equals to x less or equals to 3. Since the positive values were 3, we find this one, multiply by 2, and we get this one. Now this is greater than 0.05. That is our alpha, pre-selected alpha value. Once it's greater than that, then we make our decision by saying that once the p-value is greater than the pre-selected margin of error, we do not have statistical evidence to reject the non-hypothesis. Example number 2. A taxi company is trying to decide whether the use of gas or petrol increases their profit margin. 16 cars were used for a week with gas without changing drivers. The same cars were converted to using petrol and driven once again over a period of 1 week. It is assumed that the distance, the number of passengers carried over the week are equal. The question now is, can we conclude at the 0.05 level of significance that cars equipped with gas makes better profit for the company than those equipped with petrol? So this is what we can say. So what we're going to look at here is to say that let's do the subtraction. If actually they are making the same profit, then the sales that they are making every day should be the same. So if I use a petrol car, I should get the same profit as using a car that is using gas. So here we're going to do some subtraction to see whether or not they are 0 or more than 0 or less than 0. So we are looking at the profit of gas at the very top and then petrol at the down here. So let's subtract the down from the top as the data is displayed here. 4.2 minus 4.1, I will get a number that is positive. So I put a positive there. 4.9 is bigger than 4.7, so this will give us negative. 6.2 is smaller, positive. 6.9 is smaller, positive. 6.8 is bigger, negative. 4.4 is smaller, so positive. 5.5 is the same, so we don't have a sign there. This is positive, this is positive, no sign, positive, this is positive, this is positive, this is positive, that is negative, and this one is positive. So we look at the number of positive and minus cases. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 positive numbers, or positive signs. Then negatives we have 1, 2, 3. So we have 3 minus signs. So that makes it 14 in all. So once it's more than 10, as we indicated earlier on, if it is up to 10 or more, you can use the normal approximation to estimate or make your decision. So our null hypothesis is that if I subtract the 2, all of them should have been 0. And the alternative says that it shouldn't be equal to 0. Now, if it is this way, it means that 1 is making profits. All of them are positive, so it will mean gas. If you're using gas, it should make more profit than if you are using the petrol. The plus signs, they are 11, and then the negative ones are 3, and that makes it n equals to 14. mu is equals to, by approximation, NP is equals to 0.5 multiplied by the 14 that we just had, and this will give us 7. So the positives are 11, so by calculation we get a Z should be 10.5 for the positives, and just this 7 that we just had all over square root of the 14. That's standard deviation for approximate standard deviation from the binomial distribution, and this will give us 1.87. Alright, so the probability of getting a number as large as 11 is approximately probability of z greater than 1.87. So if we refer back to our normal distribution table, or we do this calculation in Excel, we should be able to. So we have z less or equals to 1.87. This is what we can read in the table. So we subtract this from 1, we get this one here. So if we look up this value in the table, we get 0.0307. If you have the negative table, that's fine. You can just go ahead and read that. If you don't have it, then you will have to read it in the positive table and subtract to get this probability value. So yes, we have the probability value to be less than our alpha. We decided to use 0.05, and so 0.0307 is actually less than this particular one here. So on the average, if we are going to be using gas or pay-through, we can say that gas do better or do improve our profit making than if you were to use petrol. So this is what we can say regarding our question on gas and petrol used as fuel and making profit for taxi drivers.